Hey guys, so these are the notes for Monday for week 3 of virtual learning. We're still dealing with quadratics and graphing them in Desmos and finding features that were asked for. But what's different about this lesson is that we're going to be looking at real world examples of quadratics. So hopefully you printed off this note sheet. If not, you need to go do it. And I'm going to go through these examples with you guys. So let's go ahead and get started. So for example 1, before we even get into the actual math and what we're trying to find, I want you guys to think about the scenario. So it says a football is kicked into the air, okay? For those of you that don't watch football, when you punt or kick off in football, it makes a parabola, okay? Just like in basketball, when you shoot, Amari, the ball's gonna make a parabola, okay? So anytime you throw or kick a ball, due to gravity, what goes up has to come back down. Hopefully you learned that in science and somewhere along the way, middle school, elementary school, whatever. But anytime you throw or kick a ball, the shape that the ball makes in the air is going to be a quadratic, okay, a parabola. So let's look at this sheet real quick, and I'm going to explain these notes that I typed up for you guys, and then hopefully we'll be able to understand what exactly we're looking for and what's different about parabolas in the real world than just a graph, okay? So if we look at this diagram right here, this bottom part says this 0 gets thrown out for being, and I don't like the word too negative. It basically gets thrown out because it's negative, all right? So anytime we talk about throwing a ball or kicking a ball or, I don't know, dropping something, all of those situations are done in real time, and in the real world, time cannot be negative, okay? Hopefully you learned in Math 1 that your x-axis is almost always going to be time, and time has to be positive, all right? Now, we're still talking about the football problem. So if I'm talking about kicking the football, this is the time it takes for the ball to go up in the air and then land on the ground, right? If we're talking about that football, you can also see that this, right? So think about your height. Height in the real world can also not be negative. So that's the reason, let's look right here, where it says, when does the object hit the ground? A football is not going to penetrate the ground and go underground, okay? Yes, some of my smart Alecs out there, y'all are like, well, a submarine goes underground, or you could throw something that could go underground. True, but we're talking about a football here, okay? So when the football hits right here, it's also going to stop. So this is the first big difference between just the graph of any quadratic and the graph of a quadratic that models a real world situation. In the real world, this does not keep going on forever, okay? That's not going to happen in the real world. It's going to stop. Now, this x-intercept is negative, which means time or distance, whatever you were measuring, is going to be negative, so we can't have that one. This is going to be the one that we're concerned about. So when it says, when does the object hit the ground, it wants that x-intercept. It could also say, how long is the object in the air? Again, it wants that x-intercept, okay? The y-intercept will be wherever the object starts. So if I tell you that we're kicking a football off of a tee, it basically starts at the ground, right, for kickoff. If we talk about hitting a baseball, when you hit the baseball, your elbow should be up, my softball girls, softball, okay? And really wherever that height of your arm is, that's where you're contacting the ball at, all right? Same thing, Amari, with basketball. Whenever I shoot a basketball, the ball is going to release off of your forehead. So for Miss Poole, the y-intercept should be 5'9", because I'm 5 foot 9 inches, okay? So that's how the y-intercept kind of relays into the real world. You guys know how to find the vertex. It tells you right here, the x value is when the object is at its max height, when, the time. Let's underline that because I know y'all be forgetting. Plus, you've just had spring break. I'm making this video on spring break, so crazy. All right, the x value is the time. When is it at its max height? The y value is the actual height, how high it gets, okay? You know that already though. You know how to find the vertex, blah, blah, blah. I think we're good to go ahead and get started, okay? So let's look at example 1. So it says a football is kicked into the air. Its height after t seconds is given by this equation. So you guys know by now that we can go to Desmos.com and type in that equation. So I'm going to slide mine so y'all can still see it. So we have, and I'm just going to change the h to y because we know the height is the y value. And I'm going to change the time to x's in Desmos, okay? Because we know that the time is always the x value. Pull up this right here. There we go. Sorry, my computer's being real slow, y'all. X plus 1. Okay? All right, so it pulls up the graph of our quadratic for us. I'm going to move it just a little bit and zoom out. So I'm hitting this minimize button. Okay, so this is what our quadratic looks like. So this is the model for the football getting kicked in the air. I need to go this way. I keep forgetting this camera's backwards, okay? So part A says how high is the ball after 1 second, all right? Well, to find this, if I gave you 1 second, that means I gave you the x value, okay? So I'm telling you when x equals 1, because remember your time is always x. When x equals 1, I want to know how high the ball is, right? So watch what I'm going to do. In Desmos, I'm going to click a new box, type in x equals 1, and then I'm going to zoom in so I can see where those cross a little bit better, and click and drag till I get it where I want it. And it looks like they are crossing right here. So do you see how when I clicked where I thought they were intersecting, it popped up with the point, and it's at x equals 1. But the y value is 20.6, which is the height. So when it says how high is the ball, it's 20.6, and read your problem for the units. Oh, it didn't give us units. That's not good. We're going to say 20.6, I don't know, yards. Most of the time in football, stuff is done by yards, okay? They should have given you units. That's my fault. All right, find the maximum height of the ball. Well, you guys know how to do that, so I'm going to go back to Desmos. I'm going to get rid of this x equals 1 because I don't need that. I'm going to zoom out until I find my max point right here, and they asked for the maximum height. So I didn't ask you when it reached the maximum, and let's use our brains here. Do you think 2.5 is the maximum height we could kick a football? No, all of you guys could kick it higher than that, right? So the maximum height is 31.625, and we'll say yards. Height means y value, 31.625 yards. All right, how long does it take to reach its maximum height? How long, if I asked you how long it took you to get ready this morning, since we're all staying at home, it shouldn't take you any time. I've been wearing no makeup. Okay, if I ask you how long something is though, like how long does it take you to get ready? How long did you stay up last night? How long did it take you to do your math work? You're going to give me a time. So this phrase, how long, indicates time, which means we're looking for the x value. So how long does it take to reach the max? 2.5 seconds, because the problem told us we were doing seconds for the time value. Okay? All right, and then the last one, when does the ball hit the ground? All right, so if we're talking about when this football will hit the ground, let's go back and look at our graph. And if you look, the football starts here, we kick it, it goes up, and then right here is where it's going to hit the ground. So how long was it in the air, or when does it reach the ground? It reaches the ground at 5.04 seconds. And again, that word when is an indicator of time, which means the x value. Okay? So this is all we're doing. One more time. This is different from a regular quadratic, because the graph of a regular quadratic, like just looking at a graph, I shouldn't say the word regular because they're all regular, but the quadratics we've been studying have arrows on the end, which means they go on forever. But in the real world, situations do not go on forever, okay? If I kick that football, the kick or the punt automatically stops when that ball hits the ground and somebody picks it up, right? So same with a baseball. When you hit it, it ends when somebody catches it. If they don't catch it, it ends when they hit the ground and retrieve it, right? So, I mean, real world situations do not go on forever. So we are only going to be looking in quadrant 1 for these problems because you guys just told me earlier that we can't have negative time in the real world and we can't have negative heights or distances, okay? So for all of these problems, you're going to be only looking at quadrant 1 to find your features. Sound good? All right. I don't think, maybe I'll do one more just in case. Just in case you guys need help with one more, we'll do one more. Can we just do number 2? Let's just do number 2 really quick. So for number 2, they gave us y equals negative 26. Let me move this so y'all can see it. Right here, negative 26x squared plus 260x, okay? And it says, how long does it take the rocket to hit the ground? So imagine, look at your graph, let's zoom out. This rocket went really, really far, which makes sense, it should, okay? So my rocket starts here at 0, 0. It blasts off, and then it lands right here, right? Make sure I graphed it right. Yep. All right, so right here at this point is where it hits the ground. And do y'all see how it says 10, 0? Well, that means how long did it take for the rocket to hit the ground? I'm reading the problem to find the units. After t seconds, so it took 10 seconds, okay? So that's all you're doing on today's assignment. I do want you to finish example 3 just so you have it in your notebooks. Get on Zoom if you need my help or Google Voice me, and y'all should be okay with the rest of